Okay, now let's go to backtracking and solving the n-queen problem using backtracking. Let's take a deeper look at backtracking. So in backtracking, we are creating a tree. Okay, we are creating a tree or state space tree, and every time that we see a dead end, okay, we are coming back. We're coming back to the space that we have been. So the way that the backtracking works is it's like traversing a tree in a pre-order set, okay, or depth first search. Okay, so we have learned depth first search algorithm before and how the pre-order algorithm traversing of the tree works. Okay, so it means that first in the pre-order we are visiting the parent, then the children. Okay, here we don't we don't care that which nodes which child you're visiting first, okay, because usually in the backtracking problems the tree that we are creating is in a binary tree, okay, so it doesn't matter which one you would like to choose to traverse. So in the backtracking we are doing a depth first search and a pre-ordering one, okay, so first we are visiting parent. The structure of all the backtracking algorithm are almost same. So we have a promising function or algorithm, and also the main part of solving the problem. Okay, so let's see that what the promising means. In backtracking problems, in state space tree that we have, if a node can yield to a solution, okay, or it's itself the solution, okay, we are saying that that node is a promising node. Otherwise, it is a non-promising node, okay? So before we are going further for searching like the other nodes, okay, or traversing the tree, first we need to check if the node that we are checking is promising or not. Okay, assume that in a tree that in a queen n-queen problem, you are putting the first queen on the first row and the first column, and you are going to put the second queen on the first column of the second row. So this node is not promising, okay, because if you put this, as I said, the second queen on this second row in the first column, okay, no other you cannot yield a solution, okay, because it's already two queens are attacking each other. So that node in the space tree is non-promising, okay. But for example, if we are putting the queen, the second queen on the third column, okay, then that node will be a promising node, okay. So that's what we are talking about, the promising algorithm. Okay, so let's look at the the n-queen problem using a backtracking. So if the node that we are talking is promising, okay, and the I is the number associated with the queen, okay, and as we start with this no queen at all, okay. So first we are checking if the node that we are checking is promising, then if the I, that is the number of queen or the number that we're now doing, is equal to n, because we're gonna put all the n queen in the board on the board, okay. So if I is equal to n, it means that we already have put all the n-1 queens on the board successfully. So if I is equal to n, then it means that we found a solution, so output the solution. Otherwise, if we haven't put all the queens on board, so what we're going to do is for every column that we have, then we are trying to see if that node gonna give us the solution or not. So that's why here we are calling queens recursive function with that column that we are associated, the j, that is the from I to n is the column numbers, okay, and I plus 1 is the next queen, okay. So we are assuming that we are we put the queen I at location column, okay, and then we are putting the next one here and see that if it works, okay. It's similar to what we have in the tree, and I will show you that how it's gonna be on the tree. And the promising algorithm, okay, if you see that, if you want to check that how a node is promising or not, first of all, okay, they shouldn't be on the same row. Okay, they shouldn't be on the same row. They shouldn't be on the two coins shouldn't be also on the same column, and also they shouldn't be on the same diagonal. Okay, so the left, they shouldn't be on the left or right diagonal. Okay, so this is how we are going to show that. So if the column of I is equal to column of k, okay, or the column I minus column of k is equal to I minus k, that is being on the same diagonal. Okay, if being in the same diagonal, then is promising false. Okay, and also this is for checking the column. Okay, if they are both on the same column, okay, or in the same diagonal, then promising false. Okay, and we are doing this with checking the k is the index for all the previous queens that we have put on the board so far. Okay, and the I is the current queen. Okay, so we have to do, let's say that the I is equal to 5. That means that for all 4 queens that we have already put on the board, we need to check if the node is promising or not. Okay, so for every k, check that the queen at location at row 5 is not at the same column or at the same diagonal, left or right. Okay, and that's why we have the absolute value here, because it's gonna be, might be the left diagonal or the right diagonal. And if there is no problem, okay, then we are returning is promising. If for any of the, even for one of the nodes, one of the queens, okay, the condition doesn't hold, so we are putting the is promising to false, then we are returning is promise. Okay, so that's as you see here, that's like the generalist, almost the general structure of all the backtracking algorithm. So we have a promising function. Okay, so for every node we need to check if the node is promising. Then if it's if it is, okay, we are going to do the rest of the things for going further to the tree, or like doing the pre-order. Okay, going back to our like example on the 4 queens. Okay, let's see then how this promising algorithm works. So here at first we are putting the first queen on this first column. Okay, and that's fine because there is no other queen on the board, so that's a promising node. Then we are gonna call for every other column that we have. We are gonna see that if we can put, at first this is I is equal to 1, and here I becomes 2. Okay, and see that for I equal 2, can we put the queen on any 4 columns that we have? So if I put it here on the first column, and I'm gonna like check the promising. The check promising was saying that if they are on the same column, then the promising is false. So it means that here the node is not promising, so no need to go further. Okay, and this technique is called the pruning. Okay, so that's a pruning technique, that you are removing or getting rid of the some part of the space that you have, like the search space that you have, because you know that this is never gonna give you a solution. And also here, let's do this example. So we put the first queen on the second column, but we are so I here is 1 and I here is 1. So here we are putting the second column on the first column. But if you look at the promising, because both are in the same diagonal, okay, on the right diagonal, okay, so it's not promising. So we also check this one as a non-promising node. So there is no need to go further and look further, because we already know that's not give us the solution. And so if you just continue, okay, the solution here, for example, let's draw the solution. So the queen number 2 should be at location 4. Then here we have the queen number 3 at column 1, and then also we'll have the queen number 4 at location 3. Okay, so that's a solution. Okay, and as you see, there's the promising. All of them are promising because none of the queens are attacking each other. Okay, so that's the backtracking solution or algorithm for finding the in queen problems. Okay, so and there's something I think it's required to mention that we are not actually creating the tree. Okay, so we are not creating the tree, but the way that the backtracking works is resembling like a tree, and like drawing a tree can help you for seeing that how the backtracking works. Okay, indeed, we will have just the columns that says that at each column which like at which column queen is put in which column. Okay, so that's gonna be that's what we are storing and not the actual tree for the backtracking. For any other backtracking problems that we're going to see later, okay, we are going to like create a similar approach. Okay, so writing a promising like function, and also creating the main things, the main function that checks if the nodes are promising, and if then it goes further to the tree that we are creating.